So how do we actually form metamorphic rocks, right? Where does that heat, pressure, or chemically active fluids actually come from? Well, first, we're going to talk about heat. As we know, when temperature increases, atoms start to vibrate faster. When atoms start to vibrate faster and move away from each other, it's it's easier for those bonds to break and reform, right? And that's what allows that solid state reaction. It's when a solid changes, right? Bonds are broken and remade without ever changing to a liquid or a gas. So for example, shale can turn into slate under intense heat, but it always stays a solid. And this heat can come from a few different sources. The first being contact metamorphism. This occurs anytime just a really hot magma body or some other heat source comes in contact with rocks that it metamorphoses. You can imagine a magma chamber wells up through the mantle and into the crust. That magma chamber, the heat from that magma chamber is going to radiate out and start metamorphosizing the rocks around it. So for example, if the magma chamber protrudes up into limestone, the limestone that's in contact with that magma chamber might metamorphose into marble. All right, so that's one way, contact metamorphism. And this really has nothing to do with pressure, right? It's all about the heat. The other way you can get a lot of heat is with deep burial, and this is associated with pressure as well. So as we know, due to the geothermal gradient within Earth, the deeper you go down into the Earth, the hotter it gets. So if something is deeply buried, maybe it's at a subduction zone, and it's pushed deeper and deeper and deeper into the crust and mantle, it's going to get hotter and hotter and hotter, and that's another source of heat for metamorphism. Now, I said this deep burial is also associated with pressure. Right, so let's start talking about pressure. There's a couple different types of pressure. Lithostatic pressure, meaning the force of pressure is equal coming in from all directions. Imagine yourself diving down to the deep end of a pool, and if you turn upside down and wiggle around with your eyes closed, you can't tell which way is up or down anymore. And that's because the pressure is coming onto you equally from all directions, right? So the atoms become more closely packed together, and this often causes neocrystallization. But there is no like shearing or elongation of elliptical grains, right? It just changes size, not shape. What will cause it to change shape is differential pressure. And this is when the force is not equal in all directions. Instead, it's really, really intense coming in from two directions, not so much in the other directions, more intense from two directions. And this will more likely cause recrystallization perpendicular to the stress. So this is what causes that foliation, right? The elongation of grains, that compositional layering that we see in metamorphic rocks. All right, next up, chemically active fluids. Often you'll hear metamorphism is just from heat and or pressure. Once you get higher level in geology, as you all are now, you also learn more about chemically active fluids. So even without heat, even without pressure, chemically active fluids can spark metamorphism. They are often associated with heat and pressure, but not always. So chemically active fluids, those are fluids that are rich in dissolved compounds and often metallic cations. And metasomatism occurs when there's a chemical alteration due to these hydrothermal fluids. So these really hot fluids that have a lot of dissolved compounds within them are circulating through cracks and faults and things like that. And when that groundwater, or when that chemically active fluid comes in contact with other rocks, it can cause metamorphism. Right? This is very common at subducting oceanic slabs or anywhere where groundwater is coming into contact with intruding magma.